Bueno, controlador del nivel del agua usando arduino. Primero, comenzando con las definiciones neutrales. Este es un proyecto que controla el nivel del agua en un tanque de agua que automáticamente y es de mejor calidad comparado a otros circuitos. Son muy útiles, son materiales muy útiles y permiten que un circuito se cambie a otro mientras están completamente separados. Los materiales usados para este control de nivel del agua, controlador de nivel del agua, está el arduino Mega, el HCSR04, protoboard, jumpers, resistores 4.7, 3.3 y 2.2 y UPT, cable UPT, agua y el contenedor. Bueno, ahora un video.
Hi all, welcome to yet another video from Robots, the Next Species on Earth. In this video, we will learn how to create automatic water level indicator and controller system using Arduino. Let's learn the designing and working of this project using given block diagram. The project is mainly having 6 blocks. Let's learn one by one. The first block is a 16x2 LCD display, which is the output unit. This will be mainly responsible for displaying the water level and pump status. The second block is the Arduino. This is considered as the brain of this project. This will be controlling and coordinating all the other blocks. The third block is the buzzer. We use this unit to make the project more user-friendly. This will produce buzzing sound while the water level is very low. The fourth block is the sonar sensor. This is mainly responsible for measuring the water level. The fifth block is a single-channel relay board. Arduino will be controlling the pump using this section. The sixth block is submersible pump. This will be using to refill the water tank. Let's understand the working principle of the sonar sensor. Sonar sensor emits an ultrasound at 40 kHz, which travels through the air, and if there is an object or obstacle on its path, it will bounce back to the module. Considering the travel time and the speed of the sound, you can calculate the distance. Arduino will use the echo pin, present on ultrasonic sensor to measure sound wave travel time in microseconds. In this case, sonar sensor will be placed on the top of the water tank. Here the obstacle would be the water. Water level can be calculated using the formula shown here. The measured water level in centimeters will be further converted into water level diagram, and same will be displayed on 16x2 LCD display. Buzzing sound will be produced by the buzzer and Arduino will start the pump while the water level is very low. Similarly, Arduino will power off the pump once the tank is full. Now let's move to the components required to build this project. You can purchase all the components shown here from third-party vendors like Amazon, eBay, etc. Let's move to the circuit diagram. Let's only talk about the main connections to short down the length of the video. Connect trigger pin on the sonar sensor to the Arduino digital pin 12. Similarly, connect echo pin to the digital pin 11. Buzzer is connected to digital pin 13. Relay control pin is connected to digital pin 10. Common pin of the relay is connected to positive terminal of the submersible water pump. Similarly, normally open port is connected to AC phase. Pin A0 to A5 is connected to LCD display. Voltage regulator will provide 5-volt operating voltage to Arduino. Similarly, relay is operated by 12-volt DC. Now we can move to the programming section. Make sure to download the new Ping library from the given link. This library will be downloaded in zip file. You can import this library to your Arduino software by going Sketch, Import Library, Add Library. For uploading the code, connect Arduino to your computer using the USB cable, and click on the Upload button. This will upload the code to your Arduino. Visit link given in the below description to find the code. Now we can start assembling the circuit. can see the tank is empty. Let's power on the circuit. Arduino has powered on the pump. You can see the pump is automatically powered off by Arduino while tank is full. So our project is working as per our design. Visit the link in the below description to know.
Bueno, ahora, ¿cómo se lo aplica? El HCSR04 ultrasonido, o sea, el sensor, que este aquí es un sensor, es un módulo de 4P donde los nombres del pin son BCC, Trigger, Echo y Ground respectivamente. Ese sensor es muy popular, es un sensor muy popular usado en muchas, bueno, es aplicado en varias situaciones, midiendo la distancia o determinando la sensibilidad de los objetos de acuerdo a cómo son requeridos. Bueno, ahora tenemos otro video. Bueno, ahora en cuanto a los pros y los contras. Entre los pros tenemos a que el módulo tiene dos como que proyectos, dos visiones de proyectos enfrente, los cuales forman el transmisor ultrasonido y el receptor. Y otra cosa es que el sensor funciona con la simple fórmula que se ha enseñado en el colegio, la cual es igual a distancia es igual a velocidad sobre tiempo. En cuanto a los contras, tenemos a que el transmisor de ultrasonido transmite una onda de ultrasonido, y esta onda viaja en el aire, y cuando llega al objeto, cualquier material es reflejado hacia el sensor. Tenemos otro video.
Hello guys, I'm Marian from electroschematics.com. Here is a simple Arduino project. It is a water level indicator. It shows displays the water level on an LCD display. Also it has 3 LEDs. And here I have a DC motor connected to a 9-volt battery. The working principle is quite simple. You have 3 probes, in my case this one. Green for low level, yellow for an average level of water, and red when the water level is pretty high. It's high. So all that you have to do is connect these probes at different levels, and we have a common one that must be inserted into water. It always must stay at the lowest level. And let's make a simple demonstration. I will insert the green one. For example, when the water reached let's say 20 centimeters. And now the water level is increasing up to 1 meter, let's say. So the yellow one turned on. On the display you can read average. And now if the water continues to flow into our water tank, and it reaches the highest point. You can see the motor started spinning.
You can see,
I hope you can see,
or you can hear it.
or you can hear it.
You can use
You can use
electric valve
an electric valve to open the water flow through a pipe when the water has reached a very high level inside, or the desired level. In my case, is displayed here with a LED, red LED, and on the display is writing high. Yes, high.
So you can open electric valve.
So you can open an electric valve, or who knows, maybe you want to connect a relay.
You can
configure it in many different ways.
So as you can see,
it is working, and as usual, I will post a link below this video with the page where you can read more info about it, and where you can download the Arduino sketch, so you can upload it on your board. And guys, if you liked this video, please subscribe to my YouTube channel. You have a button below this video, I think. It says subscribe, and if you're not already subscribed, press that button, and I'll try to post as many videos as I can, not only from the Arduino,
not only for the
Arduino board, but tutorials and many others interesting stuff. Thank you very much for watching.
Bye-bye.
See you next time. Bye bye.
Ahora, ¿cómo este tema se puede llegar a nuestro país? El Mega Arduino, Mega Arduino es una marca del microcontrol que es conocido a nivel mundial y es muy utilizado por los amantes de las electrónicas y la programación de la robótica. Como es un proyecto de open source, ofrece a los usuarios una gran variedad de dispositivos basados en el microcontrol Atmega. Es posible comprarlo, el Arduino armado, la placa de Arduino armado, o se puede obtener las piezas por uno mismo, y de esa forma se puede uno mismo desarrollar el producto. Y para concluir, bueno, el Arduino Mega está diseñado para proyectos complejos. Sin embargo, igual se hace mucho más fácil para los que recién empiezan en esta área trabajar. Es recomendado las impresoras 3D y los proyectos de robótica, o sea, es recomendado en estos proyectos. Y así brinda una oportunidad, brinda espacio para una gran cantidad de proyectos y oportunidades en cuanto a la robótica y la programación. Gracias.